Hi, here's a video on 2D triangle problems. Our learning intentions are understanding what angles of elevation and depression are and what the most common mistake is that's made with them. To understand how to draw a 2D problem from the side, we'll look at top-down 2D problems involving bearings in another video. Understand what kind of general method you should employ in solving problems like this, and also just to understand that these kinds of questions involve a degree of problem solving, so you won't always see what the answer is or even know exactly how you're going to find it immediately, and that's okay. The more of these questions you do, the more comfortable you'll be with that. And we're going to start with angles of elevation and depression. So, angles of elevation and depression measured from the horizontal. What that means is, let's say this guy here is in his canoe looking up at the lighthouse. We say this is an angle of elevation from the horizontal. Let's say that was 41 degrees. Well, if you were standing up at this lighthouse and you imagine a dotted line going out parallel to the horizon there, that would also be 41 degrees, and that's called the angle of depression because it's going down. This is elevation going up. These two angles are the same. They're always going to be the same because that line and that line are parallel. You sometimes get these occurring in kind of north-south bearing questions, which we'll see later. So any angle like that means this angle is the same as that angle for the same reason. And they're sometimes called Z angles. You may have heard that before. So that angle is the same as that angle, where those two lines are parallel. And it doesn't matter if that occurs like that or some other funny angle. As long as those two lines are parallel, those two angles are going to be the same. The proper name for them is alternate angles. Okay. Most common mistake that's made with them is if you are told, for example, the angle of depression is 41 degrees, and that's all we've got. And the most common mistake that's made is that people think it's this, which is not measured from the horizontal. It's just the angle at the top of the triangle there. Okay, so next we're going to have a look at the question here. We've got angle of depression to a small boat at sea is 39 degrees 25 minutes when measured from the top of a 120 metre high cliff. Find the distance that the boat is from the cliff. So we've got our boat here, cliff there. Now angle of depression is 39 degrees 25 minutes. What we're not going to do is make the mistake of thinking that it's this angle here, because we know it's not. It would be, sorry, that's supposed to be straight. It would be that angle there, which means it's also the same as this angle here. So I'll put 39 degrees 25 minutes there. And we know that it's a 120 metre high cliff, so we've got that length there, and what we're looking for is the distance from the boat is from the cliff. Now, when you're asked for things like this, generally it means the shortest distance, so you could argue that the boat is also this distance from the cliff, but that's the top. What we're looking for is this distance here along the horizontal. So it's a right angle triangle. That means it's either SOHCAHTOA or Pythagoras, and it involves an angle, so we're looking at SOHCAHTOA. And we've got the opposite and we've got the adjacent. So it's going to be tan of 39 degrees 25 minutes is equal to the opposite, which is 120, over x. We need x on its own, so to rearrange this, we're going to have to multiply both sides by x. There's 120, and then divide both sides by tan 39. Gives us 120 over tan 39 degrees 25 minutes. And you put that in your calculator and work it out. Now, generally, what I do, I prefer to work in decimals than minutes and seconds, so I'll usually take this and convert it into decimal, do my working out, and then take my answer. If I need to put something back into degrees, minutes and seconds, I'll do that at the end. This is a length, so I won't need to do that. So I can do that in the interactive transformation DMS, degrees, minutes, second bit. So I've got 39 degrees and 25 minutes, no seconds. 39.416. Now I'll go to 4 decimal places, so it's going to be 67. So we'll look at the next one, I would have to round up. So this is 39.4167. 4 decimal places is good for working out, and then you can give any final answers to 2 decimal places. Okay, so we've got our 39.4167. My decimal places disappeared. There we go. So 39.4167, and what I want to do to that then is do 120 divided by tan of that. So I could type in 39.4167, or I could drag it down from there, and it's 146.00. Sorry, that was hanging over from before because I just did the calculation a few seconds ago. So x is 146.00, or to 2 decimal places, it's 146 meters. Okay. So we're going to have a look now at a typical double angle observation problem. This is a 2D triangle problem from the side. So we're not looking top down, we're looking kind of as if we were standing on the ground looking at something from the side. Here we've got the Eiffel Tower, you can see there. And a woman standing at position A sees that the angle of elevation to the top of that tower is 35 degrees and it's 260 meters high. She walks to position B, which is closer, and finds that the angle has changed. It's now 52. Find the distance that the woman walked in between making the observations. Now what I would do, ask you to do here is just pause the video and see how much you can do without any direction. See if you can work out this problem on your own. Then what I'm going to do is go through a general method you can do for solving problems like this, and you can compare your answers as well. Okay, so first thing that you should do with any sort of problem like this in trig is to draw a diagram. So we've got our horizontal here, and we've got the tower here. We should add a few more bits and pieces in. So first of all, we know that the tower is 260 meters there. There's a woman at point A, and when she looks up to the top of the tower, she sees that it is angle of elevation of 35 degrees. She then walks a bit closer to position B, and she looks up at the tower again. This time she sees the angle of elevation is 52 degrees. So we've used that information, that information, that information, that information, that information. I think we've used everything that we have now. The second step is put in everything that you know. We've done that. The third, identify the thing that we're trying to find. So find the distance the woman has walked in between making the observations. What we're being asked to find is this distance here between A and B. So we want that length there. Now, the tricky bit, because it's not immediately obvious how we would do that, is to work out what would be a useful stepping stone, so something we could work out that would then help us work this out. So we're kind of asking ourselves the question, well, if only we knew this, we'd be able to solve it easily. Now if we knew, well actually just pause the video here again and see if you can work it out from here, then come back in a minute or two. Okay, so the thing that strikes me here is, well, if we only knew how far it was where she was from the starting point to the tower, and if we knew how far B was from the tower, then we could just do this distance, take off that distance, and we'd be left with how far away those two observations were. And I think we can work out those, that's the longer distance and the B to their distance, fairly easily. We could do the big distance first, and whenever you're doing these, always draw yourself a new triangle. So this is our first calculation here. Got a new triangle off to the side. We know it's 260 meters there. Again, put in everything that you know. 35 degrees here, and you should be able to work out what this, what that X, what that is there. So I'll just again ask you pause the video, work it out, and then check back in a second. Okay, so what we should have here is that it's going to be tan 35 is 260 over x. So if we rearrange that, then times both sides by x, divide both sides by tan 35, we get 260 over tan 35. So our distance here, x equals, over here, we'll just do 260 divided by tan 35, 371.3185 meters. Okay, that's our long distance all the way across. Now let's do the shorter one. So this is this triangle here, like that. And it's still 260 meters high. It's now 52 degrees. Oh dear. There we go. And we're going to work out this again. So this time it's the same sort of problem. It's going to be tan 52 equals 260 over x. So x equals 260 over tan 52. And we'll work that over here. Actually, we could just change it in there. And we've got 203.1343 meters. And the distance, or sorry, the distance between A and B is the difference between that distance, the long one, and the shorter one we've just worked out. So it's 371.3185 minus 203.1343 gives us 168.18 meters. There we go. That's the distance that she walked in between the two places there. So the last step in our thing that we've just done, identify the stepping stones and then use them, which we've just done, to solve the bit that we're trying to find. Okay, now your turn to have a go. Here we've got Tom standing on top of a 65 metre high building and looking due east. He can see his friend Bill. So his friend Bill over here somewhere. Then he looks, turns around, looks due west and see another friend Ben. So Ben's over here somewhere. We're given the angles of depression. How far apart are Bill and Ben? So pause the video, give yourself a few minutes to try and work it out, and then check back in a minute and compare answers. Okay, so what we've got here then is the triangle over here, 65 metres high, angle of elevation of 28 degrees, because it's the same as the angle of depression. And if we work that out using tan 28 equals 65 over x, we get 122.2472 metres. Over here, that's the distance there, that's 122.2472. Over here, here's our triangle, 42 degrees, 65 meters, solve for x, same method. We get 72.1899 meters. So the distance between Bill and Ben, how far apart they are, is that one plus that one, giving us a total of 194.44 meters to two decimal places. That being our final answer there. Okay, so if we have a quick look back here, these were our learning intentions, and hopefully you feel a bit better about each one of those now. There we go.